Okay, this is number 11 from the Unit 14 quiz. So t-shirts sell for $12 each and shorts sell for $9 each. There are 53 t-shirts and shorts. That's the total number of t-shirts and shorts sold for $570. How many of each do they sell? So from this you can get two equations to help you solve for the two unknowns. So if we use T for t-shirts and S for shorts, T plus S equals 53, and 12 times T plus 9 times S equals 570. So if we can do, you could do an elimination by multiplying by -9 or -12, or I think it's easier to do a substitution to where you can say T equals 53 minus S, and then substitute. So that'd be 12 times T, but T is 53 minus S, plus the 9S equals 570. If you multiply that through, that's 636 minus 12S plus 9S equals 570. So 636 minus 3S equals 570. So negative 3S equals negative 66, and S equals 22. Okay. Well, we had T equals 53 minus S. So T equals 53 minus 22, which is 31. So that would be 31 t-shirts and 22 shorts. Okay, this one's going to be a little more involved. We have a solve for x, y, and z. We have 2x plus 3y minus z equals 2, negative 6x minus 4y minus 4z equals negative 12, and 3x minus 3y plus 10z equals 10. And we want to, it's going to be a little bit of a process. So I recognize right off, and I saw something else after I finished working this whole thing out, that we could have divided the second row by -2 and cleaned things up, but I didn't do that. I'm just going to go through with what I did. So I'm going to eliminate y by combining the first one and the third one. So eliminate y from 1 and 3. So if I have 2x plus 3y minus z equals 2, and 3x minus 3y plus 10z equals 10, and I combine those, I end up with 5x, the 3y and the minus 3y cancel out, plus 9z equals 12. Okay? What else can we do? Let's try to get rid of y from another pair. How about eliminate y from 1 and 2. Now this one takes a little more work because they're not going to cancel out. One's got a 3, one's got a 4. So a common multiple there is 12. So I will do 4 times the first one. So 4 times 2x plus 3y minus z equals the 2. And then I'll do 3 times the second one, negative 6x minus 4y minus 4z equals negative 12. So this is going to lead us to what? 8x plus 12y minus 4z equals 8, and negative 18x minus 12y minus 12z equals negative 36. Okay, and if I were to add these two together, I have negative 10x And then the 12y and the negative 12y cancel, so the minus 16z equals, what do I have, negative 28. And then if I divide all these by negative 2, or I guess divide by 2, so if I divide by 2, I would have negative 5x minus 8z equals 14. So notice between the first equation I was able to come up with and the second one, I have a 5x and a negative 5x, so I will eliminate the x now. So I have 5x plus 9z equals 12, and negative 5x minus 8z equals, I think it's a negative 14. I think I lost my negative there. So if I combine these, look at that, I just have a z equals negative 2. Well, that's cool. Now we're going to go back and find out what x would be, and I could plug into either. I'll plug it into the first of the two that I derived. So 5x plus 9 times negative 2 equals 12. Right here, solve for x. And then I'd have 5x minus 18 equals 12. So 5x equals 30, or x equals 6. Now let's find y. We have a value for x, we have a value for z, let's find y. And you could pick any of them, I'll just pick the first one. 2 times 6 plus 3y minus negative 2 equals 2. So that's 12 plus 3y plus 2 equals 2, or 3y plus 14 equals 2, or 3y equals negative 12, or y equals negative 4. So it's going to be 6, negative 4, negative 2. That's our solution. Oh my gosh. Sorry for all the lines that showed up there. That should not have been like that. So I will take a screenshot, or take a picture of this and text the picture of my page, because it doesn't have all those lines in it. Okay.